Okay, gang, this is coal formation, the second lecture. I bet you're super excited. Why don't we just begin? To review a few things, though, there are three grades of coal: lignite, bituminous, and anthracite, right here. I listed them in order from the closest to the surface to the deepest and the least amount of carbon content to the most. Now, remember, I mentioned about that this is a business, and coal burning power plants are in the business of making money. And they have to think about the energy that they put in compared to the energy that they get out, which then makes the money. So, for example, lignite is really close to the surface of the earth. And to extract lignite might not cost the coal company a lot of money to dig out of the ground because it's really close to the surface. However, being that lignite has the least amount of carbon, it doesn't burn completely. I mean, it has the lowest heat content. So are you really going to get a lot of energy out? So therefore, the energy return on investment is probably the lowest here with lignite because you have the least amount of energy put in, which might short term look very, very beautiful. Like, hey, I don't have to put that much money into the system. But you know what? I have news for you. You might not get that much money out of the system because of the low carbon content. So, lignite, lowest energy return on investment. Now, which one has the highest energy return on investment? You got to think about this. And okay, bituminous, you don't have to dig that far compared to anthracite. And bituminous has enough carbon content where the heat output is doable and you can make a lot of money. But you might immediately first think that the answer is bituminous. That has the highest. Wrong, or maybe it's debatable. Well, what do you mean, Doc? You just told me that anthracite is the furthest down below the Earth's surface, and that's going to take a lot of money to get out. Yeah, but you know what? It's going to yield you a lot of energy, which will make you a lot of money. So you have to think about the ratio. In addition to that, you hire the right geologist to find you an anthracite seam close to the surface. Well, again, you just contradicted yourself, man. What do you mean anthracite closest to the Earth's surface? Well, check this out. Let's just say that there's this huge mountain right here, and far below the Earth's surface, you have a layer of anthracite, coal seams right here. So this is anthracite. Now, if this is the Earth's surface, oh yeah, we'd have to dig a long ways before we'd be able to extract the anthracite. But what if erosion takes place and erodes half this hill away? Now, you might not have to dig as far. Or wind and water erosion erodes the entire hill away. And now here's the new surface of the Earth because of erosion. Now you find anthracite seems closest to the surface, bada bing, bada boom. You're not putting a lot of energy in or money in, and all of a sudden you got the best grade of coal and you make the most amount of money. Plate tectonics could also push up anthracite seams closer to the Earth's surface. So with that being said, I would debate between bituminous and anthracite. If you can find an anthracite seam close to the Earth's surface, go for it because you're going to get the most energy return on investment. It's all about the Benjamins, baby, and all these people really want to do is make money. I mean, let's face it. If they can figure out a way to put the least amount of money in the system to get the highest grade coal and earn the most money out, you're going to do that, right? So riddle me this. Figure out the correlation between depth and water content. As depth increases, what happens to the water content? And if you guess B, you're correct. As the depth increases, as it gets deeper, the heat and pressure squeezes out the impurities like water. So therefore, it's low in water content. And the next question, how's the depth correlate with carbon content? Well, it's A. As the depth increases, so does the carbon content because of the first question I asked. If the water content is squeezed away, that's just going to increase the percentage of carbon content. There you have it. Now, do you ever wonder why coal is a solid and oil is a liquid and natural gas, well, is a gas? And it all has to do with the length of the carbon chain of the living material before it turned into a fossil fuel. Now, terrestrial plants are huge compared to small little aquatic life like these phytoplankton, plankton. I mean, look at these trees. Which one do you think will have a larger carbon chain? The vegetation, the terrestrial vegetation, or these little things found in the ocean? And if you guess the terrestrial vegetation, you're correct. So if the carbon chain is very long, that means there's so many more bonds that are holding this plant carbon chain together. So if there's so many more bonds and so much more extravagant, this carbon chain, it's long, full of things. Think about how much energy is needed to break apart that carbon chain to turn it to a liquid. Well, you'd be right. Which one's going to be harder to do that? Well, it's going to be the one that has a larger carbon chain. So again, coal is a solid because it comes from terrestrial plants. And terrestrial plants have large strings of carbon rings. And these are heavy and stuck together. And it takes a lot of energy to break apart these carbon chains. And if it takes a lot of energy to break it apart, then it just forms into a solid and maybe it's not exposed to enough heat and pressure to actually degrade that into a liquid to break apart those bonds. So just by glancing at this, which do you think is a solid? The one on the left, which I hope that you know that's not the case because CH4, the one in the middle, or the one on the right. And you don't even have to know what the middle one is and what the right one is. Just look at the carbon chain. Which do you think is a solid? And you guessed it, this one's a solid. Look at all these bonds that need to be broken. And because this is a huge carbon chain, it takes a lot of heat and pressure to take that solid and, melt it down into a liquid. So that is a solid. Now, in addition to it being a solid, look at coal. Since it has so many things attached to it, not only do you burn carbon and water and sulfur, but you burn a whole bunch of other impurities. There's so many bonds and so many things attached. But compare that to oil and then compare that to natural gas. And I want you to think about, okay, so how is the length of the carbon chain and the amount of matter attached to the carbon chain related to pollution when burned? Well, obviously, coal produces the most pollution. It's the dirtiest of all fossil fuels. So look at this, the length of the carbon chain versus how solid it is. And if you guessed A, you guessed right. As the length of the carbon chain increases, it becomes more solid because it's harder to break those bonds. The next question, the length of the carbon chain versus energy it takes to burn. Well, as the length of the carbon chain increases, the energy it takes for it to burn also increases. That's why coal is not as efficient as oil, which is not as efficient as natural gas. That's why natural gas is the most efficient of all the fossil fuels, because it takes less energy to break CH4 than that long thing over there on the right. The length of carbon chain versus energy efficiency. I think I just gave that away. It's got to be B. As the length of the carbon chain increases, so does the energy efficiency. Why, you ask? Because it takes less energy to break the bond, so it's more efficient. And I kind of just answered this 2 minutes ago. The length of the carbon chain versus the amount of pollution produced when burned. If the carbon chain is longer, like this thing right here, you have more attached to it, and when combusted, it produces more pollution. All right, I hope that you learned about how coal forms. I think we've seen this map before. This is where most of the coal is around the United States. And look where we are, smack dab right in the middle of coal country. So thank you for listening. And my next lecture is going to relate to this. Why do you think we should care how much coal we actually use? Because it saves us money. All right, Native Command out. See ya.